Okay, there we go. Now, this is the discussion of the quiz about energy and state transitions, and we're gonna work through this quiz quite quickly. Now, the first question, 15 degrees Celsius to Kelvin. Now, from degrees Celsius to Kelvin is plus 273, so it means 15 plus 273 is 288 Kelvin. Same way in the next one, plus 273, and then we get to Kelvin. Now the other way around is minus 273, so this will be 975. When we're working with temperature change, it's slightly different. First, we're just gonna see how much this changes. Minus 30 to 40, that's a change of 70 degrees Celsius. If the temperature lowers, then it's important to put the minus sign in front of it, minus 120 Kelvin. From degrees Celsius to Kelvin, we just saw that it is plus or minus 273, but when we're talking about temperature change, it's different, because this actually is 299 Kelvin, and this is 309 Kelvin. So it doesn't matter if I take the temperature change in Celsius or Kelvin, both is 10 degrees Celsius or 10 Kelvin. Okay, next exercise. We are first gonna take the information. A LED light connected to the plug socket, 230 volts, uses 8280 joules per hour. Calculate the current, so this is what we want to know to turn the LED light on. Information, U equals 230 volts, so that's the potential difference. Then the other one is power. It's 8280 joules per hour, but we have to know that power is indicated in watt or joules per second. Now, in 1 hour you find 3600 seconds, so divide this by 3600 and you get 2.3 joules per second. We want to know the current, I. That brings us to the formula I equals P divided by U, 2.3 divided by 230 equals 0.01 amperes. Note that the answer at the end has a quantity in front of it, unit behind it, and there's the number. Okay, let's take the next one. Little more understanding. Now, a solid substance is heated for 40 minutes. So on this part we have a solid. That means if the temperature stays the same for a certain time, it is melting. And after that it's a fluid. This is the process this way. If we would call it if we would take it the other way, we're talking about freezing for this part. From a fluid to a solid, that's freezing. Temperature for both state transitions is the same. So this is the freezing point. It is T equals 370 Kelvin. Okay, if we're talking about potential energy and kinetic energy, then we see that the kinetic energy for this part increases. It stays the same state, so potential energy stays the same. For this part, potential energy changes, and for this part, kinetic energy changes. So the question, between 12 and 40 minutes, what happens to the potential energy? Actually, it's nothing, because only the kinetic energy changes for this part. In this state transition, the temperature at 370 Kelvin, at the start it is solid, at the end it is a fluid, so in the meantime it's a mixture of both of them. That means that what is the state, then it can be both. Now, the next question is about translations. You have to know this list and there are more answers possible. But for stollen, we could say crystallization or solidification. For sublimeren, we can, for example, take sublimation. The other way around, deposition. The Dutch word for it is, for example, rijpen. For fusion, the Dutch word is smelten. Okay, more answers are possible, so different options. Last question is about understanding. You didn't learn the formulae to make these calculations yet, so this really brings up some deeper understanding in what you know about this stuff. You have to see in this example how we have to deal with this. To heat up a kilogram of ice, you need 2200 joules for every Kelvin. So it means if I want to heat up ice, and I want to heat it up 1 degree Celsius or 1 Kelvin, then I need this amount. For 10 Kelvin, I need 10 times this number. For 20 times, and so on. For water, so that is the melted ice, this is 4180 joules. It's a little more, so we have to make a difference between ice and water. Different parts of the graph that we saw here before. Okay, melting ice takes 300,034 joules for 1 kilogram. We were talking about a kilogram, so that means for every kilogram this number. If I had to melt 2 kilograms, I need twice this amount of energy. Calculate how much energy you need to heat up a 1 kilogram block, so that was what we were talking about, 1 kilogram, of ice from minus 20 degrees Celsius to room temperature 20 degrees Celsius. So we can see this graph again. From minus 20 it heats up to the melting point, then it melts, and then it heats up even more until it is 20 degrees Celsius. So we have to split up in 3 parts. First part is from minus 20 degrees Celsius to 0 degrees Celsius. Second part is melting. And the third part is from 0 degrees Celsius, the melting point, to 20 degrees Celsius. Okay, now the energy required will be the sum of this. So we're going to deal with this question in 3 or actually 4 stages. First stage, 2200 joules for every Kelvin. Joules per Kelvin. Now the temperature change is 20 degrees Celsius or 20 Kelvin. So what is the energy? Q equals 20 times 2200 equals, now my box is a little too small, 44,000 joules. And next one is the melting. We needed 334,000 joules per kilogram. Now we only had 1 kilogram, so the energy is 334,000 joules. Now later on this chapter you learned what formulae you had to use for this kind of calculations. On this point of the quiz it was not completely clear to you yet, so we can be quite flexible about how you write this down. Later on, after you dealt with formulae, you have to do this very neatly, just the same way as we did it over here. Okay, there we go again. Last part, 4180 joules per Kelvin, because this is water, it's the fluid above the melting point. Delta T is again 20 Kelvin, so that makes Q equals 4180 times 20 equals 83,600 joules. Now the total energy is the sum of these parts, because we first have to do this, then that part, and last of all that part. So at the end we can find total is 44,000 joules, 4,000 joules, and last of all 836 joules. And the sum is Q equals, quick calculation, most of you will need a calculator for this calculation. And there we have the answer. Now in this question, I'm quite flexible about how you write it down. It's important to notice that we have 3 different stages and what you actually have to do. And at the end that you can make a sum. So those 3 things, that's what I'm looking for in the answer. Okay, last of all, the bonus question. If I would draw a quick thermometer, then at minus 18 degrees Celsius, I would say 0 degrees Fahrenheit, and at 37 degrees Celsius it is 100 degrees Fahrenheit. So 100 degrees Fahrenheit fits to 55 degrees Celsius. So for every degree Celsius, 1 degree Celsius equals 100 divided by 55 degrees Fahrenheit. Now if we start on this point, 0 degrees Fahrenheit, then the temperature in degrees Celsius raised 25 from minus 18 to 25. That's a total of